last week we went over this stuff together. I got you started on this activity. You were supposed to get teacher checks on the equations to make sure that you had them correct before typing them into the graphing calculator. We started out with f of x equals x times x plus 4 times x minus 3. We multiplied that back together, and then you were supposed to make a graph. We used our end behavior. We used the x-intercepts, and then I just asked you to graph it on the calculator to fill in the rest. And when you graphed it on the calculator, you should have gotten something like that. Okay. We're going to come back to that in a moment. I told you every time you graph stuff in the calculator, graph the factored form. We talked about finding the degree. You would need to multiply all of this out. I didn't finish multiplying this out for you. You were supposed to do that on your own. But if I do finish multiplying it out, it doesn't even matter that I multiplied the entire thing out. Because what do I look at for the degree? You're supposed to have hats on. Okay, you can't have a hat on. Do you want this on this video? I'm sorry, dear. I'm making him take his hood off. Okay. Sorry, where was I? Yeah, it's the first term with the highest exponent. So if I were going to multiply anything further past me just distributing here, everything further than that is going to be a lower exponent than x to the 4th. So that's my highest exponent I'm going to have, if I kept multiplying this out, which I'm not going to. So what's my degree for this one? 4. When the degree is 4, that tells me that my end behavior is going to be up. Or it could be down, but I didn't put any negatives to make these down. Just have them up. Then I asked you to sketch it on the graphing calculator and graph what you see. Now, any of these that you didn't sketch on the graphing calculator, or at some point I am going to pull Desmos out. If you want to play along, Desmos is where I would recommend you do most of this work. The graphing calculator just gets sometimes difficult to see. So for this one, I've got those 3 x-intercepts plugged in, and I didn't graph. Oh, because I turned it off. There we go. And when I graph this one, I can see I have to zoom really far out to kind of see what the full graph looks like. Oh, there we go. I can zoom out to see what the full graph looks like, but what I notice about this one, when I made x plus 4 to the second, something different happened at -4 that didn't happen on the first graph. So I'm going to sketch. It's not perfect whatsoever. But can somebody in their own words explain what happened at that x-intercept, -4, because the -4 was squared in the equation? How could you describe what's happening there in your own words? It's different than what happened on the first one at -4. Instead of went down, it went up. So I'm not sure exactly what you mean, but I always look at the graphs from left to right. I always look that direction. So I'm thinking it's going up. Is that what you're talking about? Or were you talking about something different?
Yeah, like that left arrow goes up.
Oh, the end behavior? Of course, the end behavior changed because our degree went from a 3 to a 4. So the end behavior changed. But why? Or maybe explain in your own words, what is happening at -4 that is not happening at 0 and is not happening at 3 and didn't happen at any of them here either. We could do another one if you don't quite know how to describe it yet. Imagine you're riding the roller coaster. Well, yeah, the squared is in the equation. I want to know what's happening on the graph. Imagine I'm riding the roller coaster. This is the first one. I'm riding the roller coaster and I'm going up and I just go right through -4. Then I go down and I just go right through 0. And then I go up and I go through 3. So I go through. But what happens at -4 for this one? I'm riding the roller coaster and right at -4, I'm not going through it. What am I doing?
You're going on it like
How can we describe?
bounce.
Ooh, like a bounce? It goes down and it bounces right back off? Right on that axis. Is that a good word? I think it's a good word. We have a bounce. Like right on the x-axis, we kind of bounce. And is that happening at 0? No. Is that happening at 3? No, those just pass right through. Okay, and then from there, you guys had to go and write other equations and get teacher checks. So we're going to go through and check those. H of x. This one we always, for all of 1 through, I don't know, 7 or something. I think there's 7 of them. We had to start with the same basic x-intercepts. And then this tells me that my x-intercept 0, 0 has a multiplicity of 2. So what do I do to the equation to make a multiplicity of 2 at that x-intercept? What do I do to the equation? You guys got teacher checks on it. A lot of you did. What do I do? Square the x, that first factor, the one that would say x equals 0. Square that. And then we go and we graph. And like I said last time, there will be intercepts at -4, 0, and 3. That hasn't changed. We need to know our degree. So you can multiply these all together. When we multiplied the 3 of them, we got x cubed plus x squared minus 12x. This one, I would have to multiply by 1 more x. So I'd get x to the 4th plus x to the 3rd minus 12x squared. Again, I didn't even need to finish multiplying all of it out because I just need to know the highest power for the degree. So what is that highest power? 4. The degree is 4. So that's telling me we're going to have an up situation again. Then you're going to look on your graphing calculator, or I can look on my Desmos here. I'm moving that squared to be on the x. And now, what is happening at 0, 0? There's a bounce. Bounce is on the bottom, where before it was on the top, and that's not going to matter. What matters is that there's a bounce. So we know that where am I at? We know that the end behavior goes up at the very ends, and we know that 0 has a bounce. So I have to connect this in a way that can bounce 0 and fulfill all the rest of the end behavior. So this was stuff that you guys were supposed to do already. I am well aware that some of you don't do all of your assignments. So definitely plug things in where you're missing. What I am doing is I'm going to try to give you ways of graphing this with no graphing calculator. So you notice I'm not being very accurate. I'm putting the ends and where there's bounces, and I'm figuring everything out. If I look at my graph, one side goes way lower than the other on those little minimums. You see how this one goes way down to, I don't know, -54 point something. This one only goes down to -24 point something. I'm not worried about that accuracy. I'm just worried about everything else, that you get like the general shape of it. So as I'm doing this, if you didn't do it the first time, start thinking about ways you could do it without the calculator. Okay, so right at 0, we had a bounce. I didn't write it yet. On that x-axis, we bounced off that x-axis. It happened to be on the bottom because of where all the other x-intercepts were and what our end behavior was. All right, number 4, we're still using the same x-intercepts. And what's this one called? M of x. So I'm going to start with that x plus 4, that x minus 3. But this time, the intercept 3, 0 has a multiplicity of 2. How can I show that 3, 0 has a multiplicity of 2? Nathan. Put the squared on the x minus 3. Then we go and we graph it. Nope, I lied. Now we find our degree. So we've got our x, what's the original one? X cubed plus x squared minus 12x. That's multiplying the first 3 out, right? The x times the x plus 4, x minus 3. And then we're going to multiply by one more x minus 3. But I only have to multiply it out so I get the highest exponent, which if I take x times the highest exponent, x cubed, I will get my highest exponent of x to the 4th. So my degree is 4. My end behavior, up. X-intercepts, -4, 0, 3. Are there any bounces? Where? 3, 0, yeah, at 3 on the x-axis, yeah. So I know it has to go up on that side. I know it has to end up on this side, but I know there's a bounce. So now I just need to connect it so nobody else has a bounce. So sometimes it looks terrible and you have to erase it and try it again. But you got to connect it so at -3 there's a bounce. I mean +3, sorry. Bounce at 3 on the x-axis. And then the other two don't have bounces. Is there a question about anything I've done so far? Nope, let's do another one. So we've got a of x, and we're going to start with those same x-intercepts. This is just me copying and pasting a bunch of times and then changing where the multiplicities are when I made this up for you guys. So this time, x-intercepts -4 and 0, 0 have a multiplicity of 2. Who can describe, somebody new who hasn't talked yet, who can describe what I can do to the equation? Gavin? Square the x and square the x plus 4. That's what's going to give me the, quote, multiplicity of 2. And you guys, what that is meaning is that's just saying like a of x is equal to x times x plus 4 times x plus 4 times x plus 3. That's what it means. So I can multiply all this stuff out, or you might have an idea of what the degree is without multiplying it out. Just curious. Does anybody know what the degree is without multiplying it out? The degree is 5. Is that you, Derek? The degree is 5. Did anybody else think maybe it was 5? Okay. Corey, why did you think it was 5?
There's 5 x's.
There's 5 x's. Exactly. When I wrote it all out, here's an x, here's an x, here's an x, here's an x, here's an x. There's 5 x's total that will end up multiplying together and getting x to the 5th eventually. So I'm looking at how many x's we have. By the way, I didn't ask this question, but what's the leading coefficient? We only care that it's positive or negative, but just curious, what is the leading coefficient? It is 1. Because if I multiply all the x times x times x times x, I'm only going to get x to the 5th. So it would be 1 for this one. Okay, so now on our graph, 1, 2, 3, 4. 1, 2, 3. Our end behavior for a degree of 5 is kind of like a line when they go different directions. And since it's positive, it's going to go from down to up. So I know this is going to go from down to up. I know that for sure. I also know some more things, which is why I curved it when I drew the -4. I don't know if you noticed I curved it. I didn't draw it straight. Why did I curve the -4? Because there's a bounce there. So there's a bounce at -4. There's also a bounce at 0. So I just have to figure out how I can draw this. So it passes through 3, but it bounces at -4 and bounces at 0. There. So I got it to bounce at -4, bounce at 0, but pass through the 3. Okay? And these are things you have to do for your assignment tonight without a calculator. By the way, you want to see something really cool? I know you do. I know you do. Besides these being bounces, let's try to ignore the other ones, and let's just look at one of them. When you graphed things that looked like just this shape, just where I zoomed in, not the rest of the picture. Try to cut out the rest of the picture. When you guys graphed stuff like that, what was the degree of those? What are these things? Parabolas. When you graph those, what was their degree?
2.
Always. It was a squared. It was like x squared plus stuff. Every single time we spent 2 chapters on it. And here at -4, there's a square. There's a square, and it looks like a parabola. There is a squared at 0, and it looks like a parabola. Right there, right at that one point, looks like a parabola. Is there a squared at 3? No, there's first power. And when we graph things that are first power, they look like lines. And guess what this looks like right here?
A line.
It looks like a line. The behavior right at that x-intercept is the same as the behavior if it was like a graph by itself. So if it's to the first power, it's going to line through. This is the second power, it parabolas. Now you can totally say bounce because that's a really good like teenager-friendly word. But the end behavior is the same graph that it would be if it's just by itself. All right, let's do the next one. So we've got the same old. What are we at? B of x, x plus 4, x plus 3, no, minus 3. And then what has multiplicity of 2? -4 and 3. So Carson, can you tell me what I do to this equation? Not to find the degree, to show the multiplicity. How can I show the multiplicity?
Put a square behind x minus 3.
Mm-hmm.
X or x plus 4.
Mm-hmm. Yep. And what about the x? Yep. All right, so then what would be our degree? If you need to write it out, it'll be x plus 4 times x plus 4, x minus 3 times x minus 3. I ran out of space, sorry. If we need to write it out, what's our degree? 5. So we know our end behavior is going to be not like a line. It's not a line, but it would be like a line where we're down and up. -4, or 0, and then +3. We know it's going to go down, then up. We've got bounces at -4 and at +3. So I'm going to start down, and I'm going to bounce at -4. I'm going to pass through 0, and then bounce at 3. Now, if I'm not feeling very confident about this, it's an assignment. It's not a test. You could type it in and check it. I already have some of it somewhat typed in. I mean, I feel confident about it, but I hope so since I'm have a degree. But I'm just talking about you guys while you're at home and doing it. You don't feel very comfortable. Like, graph it and look. You see, I have the down. It goes bounce, goes back up, then it comes back down and bounces again. And you could always change how you're looking at Desmos if you want. There, I spread it out a little bit so you can see it a little bit better. Okay. Where are we at? Number 7. Okay, so this is the last kind of learning one. C of x. We'll start with those same 3 x-intercepts. And this time, all 3 of them have a multiplicity of 2. If there's a multiplicity of 2, that means I square them. So what's our degree? 6. We've got x plus 4, x plus 4, x minus 3, x minus 3. We've got 6 of them total. 6 factors. So if it's a 6, we have a end behavior of up, up. What happens at -4 on the graph? Bounce. What happens at 0 on the graph? Bounce. What happens at 3 on the graph? Bounce. So I got to make it bounce, 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 and end up, up. So if you need to erase, because it takes a little bit of effort to figure this out, maybe it takes a couple practices to figure it out and make it look good. Bounce, 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 both ends up. So my goal is that you don't have to multiply these out to figure out the degree. And you won't need your calculator to sketch an approximate graph. Again, it's not going to be 100% accurate, but the x-intercepts will be. The end behavior will be. So question 8, you need to answer on your own. In your own behavior, what does the multiplicity of 2 do to the behavior of the graph at the x-intercept? In your own words, if there's a multiplicity of 2, what happens at the x-intercept? In your own words. In your own words. You write it down. You don't have to tell me. You just write it down. And then number 9 we'll do together as well. Okay, so number 9, it says to go back, and we're not going to take the time. We're going to just do it together. It says to go back and do the same thing that we were doing with the squareds, moving the square on different factors and seeing what those graphs look like. It says to try it with cubes. So I on Desmos just made x minus 3 cubed. So if there's just an x or x plus 4 to the first, it's going to pass through like a line. But what happened when it was cubed?
It made like on the 30, like.
Yeah. One way to describe this graph is, first of all, it doesn't bounce. You see, it doesn't bounce. It does pass through it, but it doesn't look like a line when it passes through it. In geometry, perhaps you learned the words concavity. That's where it's like dented, kind of. But there's like a concavity here down, and then this concavity is up. Another way to think about it would be like if this was a parabola facing up, and then I just took the left side and faced it down. If I took like half my parabola and went burp and moved it upside down, that's kind of what that looks like there. So when we have a 3, it's going to look like a cubic shape, that's a cubic shape, which we're going to do more with cubics in a different chapter. But that's what the shape would look like right there. Let's see, I'll put a squared in X and see what that looks like. So here, if I've got an X squared, it bounces. If I have an X minus 3 to the third, it cubes it right there. It passes through, but it does not bounce, but it has that little curvature in there. Okay? Not going to give you a lot of cubes. We're going to focus more on just like understanding the multiplicity. Occasionally, maybe a cube, not a lot. So you want to summarize, repeat the process. What does the multiplicity of 3 look like at each intercept? All right, then question 10 is, did you learn something? Non-calculator. Find the end behavior, the x-intercepts of the given function. State any multiplicities, then sketch an approximate graph of the function using only the end behavior, x-intercepts, and their multiplicities. So the first thing we need to do is find the degree. So this is a completely different question than the first 9. We need to find the degree. If you need to write them out, Grayson, did you get the degree? What'd you get? 7 is correct. So the degree is 7. If you wrote them out, that's one way of doing it. If you didn't write them out, but because you know that x squared would be x and x, that's fine. But there's a total of 7 linear x's. There's a total of 7 x's being multiplied here. So the degree is 7. What is the leading coefficient? So I'd actually have to multiply those 7 x's together. Sammy, do you know what the leading coefficient would be if I multiplied all 7 of those together? Right. There's no coefficients on any of those other than 1, so it would be 1. That's not going to always happen. Just a little peek at your assignment. The next page, your assignment number 1. You have to do the same stuff. What's the degree of number 1? It's 3. There's no squareds or anything. It's 3. So we multiply that, and there's 3 x's. But the leading coefficient, you're going to actually have to multiply out 1/8 times 2x times x times 3x to actually find the coefficient. I guess you don't need to multiply the x's because the x's tells me the degree. But the leading coefficient, you're going to have to do 1/8 times 2 times 1 times 3, which is 6/8, which is 3/4. That was too thick. Sorry. Let me fix that. So there's my leading coefficient. So you're doing the degree and the leading coefficient the same. You just have to multiply the first part of the factor for all of those. Or I guess I shouldn't even say the first part of the factor. It's like the x part of the factor. All right, and then from there, you can figure out your end behavior. You should easily be able to find the x-intercepts. How many x-intercepts will there be for this one? The degree is the same as the number of x-intercepts. Same as there. So how many x-intercepts should there be? 3. So if somebody's telling me 4, what are they thinking with an extra x-intercept in there, Jack?
Are they thinking that 1/8 is multiplied by x?
Maybe. But I'm sure it has to do with the 1/8. Yeah, who knows what they're thinking? I'm just joking. But yeah, this happened in my last class. That's why I brought it up. 1/8, like if you set it equal to 0, there's no x's there. So there's no x-intercepts. Plus 1/8 does not equal 0 ever. Okay, go back to this one that we're working on. X-intercepts. How do we find the x-intercepts? Don't tell me you just take the opposite. Don't tell me that. Corey.
Set each of them equal to 0.
Right, and there's 7 of them. But if I do x equals 0 for the first one, do I need to do x equals 0 for the second one? They're the same answer, aren't they? Okay, so I got to do x plus 5 equals 0. So what does x equal? -5. So I need to do x plus 2 equals 0. So what's x equal? -2. So I need to do I need to do x plus 2 equals 0? No, I don't need to, because I'm going to get 2 of them, same answer. I'm not going to finish it. You guys got to finish that. I'm going to go over here. There is a blank for every x-intercept. So our first one was 0, 0. Whoa, why did I write as an ordered pair? It says intercept. Ordered pair. Then we had -5, 0. Then we had -2, 0. And there's 2 more that I didn't finish. Do any of those have multiplicities? What has a multiplicity here? How do I know there's a multiplicity? There's 2 of them. It's squared. Well, there could be 3 of them, but I can look at the original equation and notice the squares, or I can look at my written out one where I've got x equals 0, x equals 0. There's 2 of them right at x equals 0. What's going to happen on the graph at x equals 0? It's going to bounce. So we have at 0, 0, we have a multiplicity. So this is what I want you to write. Multiplicity of 2. And then if you need to tell yourself, that's a bounce. To remind yourself when you graph it, that's fine. But this is what you're going to be doing in your assignment, is like writing the x-intercepts, writing if there's any multiplicities. So I did not finish that one for you. Should I just finish it? We only have like 6 minutes. I'll finish it. Do any of the other 2 that I wrote down have multiplicities? -2 has a multiplicity of what? So that's a bounce. What are my other x-intercepts? I didn't finish them. I'm not going to write down 1 and 4. I'm going to write down an ordered pair. So I didn't write down anything about end behavior, but it's a degree of 7. So what's a degree of 7? Tell me about end behavior. It's odd. So we've got down up. Since the leading coefficient is positive, down up. If it was negative, it would be, flipped. So I've got x-intercepts at 0, -5, -2, 1, and 4. And I know that the end behavior is down up. Now I have to create this so that we have a bounce at 0 and a bounce at -2 and ends where it needs to end. Straight line through the other ones. Bounce at 0, bounce at -2. So bounce at -2, bounce at 0, straight through the other ones. Yeah. And then if it's ugly, then I erase it and try it a second time. Or a third time. There's better. So I've got a bounce at -2 and 0. And then the other ones just pass through. So your assignment is going to start out exactly the same as that. And then the very last page, if you guys got questions about that, you can ask me tomorrow, and I'll have this due on Wednesday.
Is this the last page?
Yeah. The last page, you might have questions. We didn't try any like that, but you're supposed to use what you learned to do the last page. But if you have questions on it, bring those questions to me tomorrow, and then I can answer those. And this won't be due till block day. Okay?
Will we have you on Thursday or Wednesday?
I don't even know. What bell is this?
This is Thursday.
5th. Is it
We
Thursday?
have second bell and then we have.
2nd, 4, 5,
Yeah.
6.
Yeah.
Okay. So then I guess it's Thursday. Thursday. Yes, because I have to have my 4th bell both days.
You don't like it?
No.